Hello students, I am Smita Patnaik of Electronics and Telecommunication Department. So today we are going to discuss about a new topic and that is nothing but your super heterodyne receiver. So let's start super heterodyne receiver. So before we are going to discuss this super heterodyne receiver, we have to know about receiver. Means a receiver means is nothing but a electronic equipment which picks up the desired signal and rejects the unwanted signal, amplifies that signal and demodulate the modulated signal to get back the original modulating signal. Okay, so this means we can receive the signals that is modulated and noise free signals. Okay, so here classifications of this radio receiver means first depending upon the application and depending upon the fundamental aspects. So depending upon the applications, the radio receivers is generally five types. Okay, so first one is your amplitude modulation broadcasting receiver. Second comes to your frequency modulation broadcasting receiver. Third one is your communication receiver. Fourth one is your television receiver, and fifth one is your radar receiver. So next, depending on the fundamental aspects, it is classified into two types. First one is your tuned radio frequency receiver, and second one is your super heterodyne radio receiver. So here our topic is super heterodyne receiver. Okay, so super heterodyne receiver means actually what happens in this case, this transformation is made. Okay, this transformations of signals is made by a super heterodyne receiver. Means here the received RF signal must be transformed in a video signal to get the wanted information from the echoes and noises and what disturbances. So this transformation is made by super heterodyne radio receiver. The main it is a type of receiver which mixes the received signal frequency with the frequency of the signal generated by a local oscillator. Heterodyne means what? Just mixing. Okay, it mixes an signal with an reference signal. So let's start. Here are some components of a super heterodyne radio receiver. Okay, so what are the components then used? First one is your receiving antenna, RF amplifier, local oscillator, mixer, IF amplifier. IF means what? Intermediate frequency amplifier, demodulator, and last one is your audio amplifier. Okay, in super heterodyne receiver, changes the radio frequency signal into a easier IF frequency signal. IF means what? Intermediate frequency. Radio frequency means nothing but a high frequency signal. Okay. The super heterodyne changes the high frequency signal into a intermediate frequency signal. So this is the block diagram of super heterodyne radio receiver. Okay. Here just see the components: antenna, RF amplifier, next block is your mixer and IF amplifier, demodulator, F amplifier, and last one is your speaker. So let's start one after another, discuss about one after another. Okay, so here first component is your receiving antenna. Okay, what happens in case of receiving antenna? Antenna means what? It receives all the signal which is present in the what? Transmitter. Okay. Here what happens? It receiving the signal which was sent by the transmitter. Okay. Here it is used as a channel or one medium in which the transmitter signal is received. Okay, here the antenna converts the electric current to radio waves that are transmitted out in all directions. So next, the antenna generates a small amount of current which varies depending on the strength of the signal. Okay, it receives a high frequency signal which is transmitted by the transmitter, and that is converted into a what small amount of current. Okay, so this is the function of your receiving antenna, and that signal which is received by the receiving antenna is given to the RF amplifier. Okay, here RF amplifier means its function is here the RF carrier comes in from the antenna and is applied to a filter circuit. Okay, the output of the filter are only the frequencies of the desired frequency band. These frequencies are applied to the mixer. Here what happens? A high frequency signal which is transmitted by the which is received by the RF antenna, which is received by the receiving antenna and accepted by the RF amplifier. As the signal tuned in such a way that it can choose the desired carrier frequency, and after that it amplifies that signal. Okay. Next come to our local oscillator. Here what happens? The local oscillator is used the circuit. It is nothing but a one circuit which basically generates a signal with a fixed frequency. Okay, and that output is fed to the mixer. So here a local oscillator, the function of local oscillator is uh, it excites a frequency for mixing with the incoming signal to get the intermediate frequency. Okay, for example, in most radar receivers use megahertz intermediate frequencies with a value between 30 to 75 megahertz. Okay, in case of a local oscillator, it is just used like a reference oscillator or which produces a reference signal. Okay, here the incoming signal is compared with the reference signal. So it is that's why it is called as the heart of the receiver. Here this frequency conversion process, also called the heterodyne, produces the sum and difference frequencies from the frequency of the local oscillator. Next, mixer. Mixer means what? Generally mixes. Who? It is the device which is used to mixes. Okay. Here, two signals are mixed with each other. First signal is your input signal, which is coming from the RF amplifier, and the second signal is our local oscillator signal, means a reference signal. Okay, here the mixer stage is used to increase the received frequency to an intermediate frequency. Okay, the summation of the carrier and the local frequency oscillator at the output of the mixer will give rise to image frequency. So here it is treated as a type of noise or distortion in the signal. The difference frequency is called intermediate frequency. Okay, here the it mixes two signals. Here these two signals are beat together to obtain the intermediate frequency through the process of heterodyne. Okay, heterodyne means what? Mixes. That's why it is called, here two signals are mixed. That's why it is called a super heterodyne radio receiver. So here we can obtain two signals in the mixer, and it mixes up, and finally there are any component which can distinguish a negative frequency of a or a positive frequency. So next component is our IF amplifier. So what is the function of this IF amplifier? Here IF means what? Intermediate frequency amplifier. So generally we know amplifier means it amplifies the signal, means it can change the weak signal into a stronger signal. So it after it is the RF frequency is converted into lower intermediate frequency. It is then amplified. It provides a sensitivity and selectivity to the receiver. So these are two main basic components, that is sensitivity means it is generally called as gain. Gain means what, students? Gain means it is a efficiency. Okay, efficiency means what? It is the ratio of output to input. Okay, so uh, gain efficiency, if sensitivity is more, then we get the 90 about 90% of the original signal. Then one more what component is there, that is selectivity. Selectivity means what? Bandwidth. Bandwidth means a difference between two frequencies, either high frequency to lower frequency. So these are the two main basic regions. For that we are using here a super heterodyne radio receiver. First one is your good selectivity and good sensitivity. So intermediate frequency IF amplifiers are the amplifiers used to raise signal levels in radio and television receivers. Generally, what happens in television, it is lower signal. So, we cannot give direct RF frequency signal to the television. That's why we are changing the radio frequency into our intermediate frequency by this IF amplifier. Okay. So, next come to our demodulator. Demodulator is nothing but a one type of detector. Okay, so detector, so what's the function of detector then? It extract. Okay, it is placed exactly after the IF amplifier so that a constant frequency signal is demodulated and the message signal can be extracted from it. And we are combined two signals. One is reference signal and second is your input signal. So it is extracts our original baseband signal from that reference signal. And finally, it extracted the signal and amplified by using the audio amplifier. Okay. So next component is our audio amplifier. Amplifier means you know. Then audio means what? Audio amplifier means the original signal is fed to the audio amplifier which doesn't hold distortion or noise, which does not hold distortion or noise, so that it can amplify audio signal to a particular level. Okay, here audio amplifier means it gives signal quality uh, without any distortion, noise. So we what we get the original message signal without any noise and distortion by using this audio amplifier. So next come to our power amplifier. It helps in activation of a loudspeaker. The power amplifier is always used in the output section. So here in case of output section is what our receiver section. So here our topic is super heterodyne radio receiver. So receiver means obviously here we are using power amplifier, which the additional gain is produced at a single predetermined frequency by the intermediate frequency stage. Okay, by using this, we can activate our speaker. So this is all about your super heterodyne radio receiver. Here are some advantages of that radio receiver. Okay, it can operate at a low signal level. Second one is more cost effective and provides frequency stability and selectivity due to tuned oscillator rather than a tuned amplifier. Okay, next some applications which are using, that is in televisions, in radio receivers, next in modems with what? First is your modulator and demodulator devices, and used in satellite communications, set-top boxes, and radar and radio telescopes. So these are the some applications in which super heterodyne radio receivers are used. Okay, so this is all about our super heterodyne radio receiver. Thank you.